Okay, this is the solution for the first potential paper for C3 Edexcel 2018. The first question, so we have to do a proof, sec squared theta bracket cos 2 theta minus sine squared theta. So that equals to sec squared theta bracket 2 cos squared theta minus 1 minus 1 minus cos squared theta. So I just made everything into cos thetas. And then sec squared theta equals to 2 cos squared theta minus 1 plus cos squared theta. And that is sec squared theta bracket 3 cos squared theta minus 2. And if you multiply it out, you get 3 minus 2 cos squared theta. Question 2, part A. So f of x equals to 2x plus 1 squared minus x plus 1 minus 2 all over x plus 1 squared. I made the common denominator, and if you just simplify, you get the answer at the end that's required. For part B, you just complete the square, you take the 2 out of the bracket. You can keep the 1 out of it or keep it in there, it's up to you. I just kept it out, it's easier, and then you just simplify it and you get 2 bracket x plus 3 over 4 squared minus 17 over 8. So the c, value c, is minus 17 over 8, as the function is always greater than minus 17 over 8. Part C, so you just had to find the derivative. So all I did is I let u equals to the top, which is 2x squared plus 3x minus 1, and v equals to x plus 1 squared, differentiated, and then use the quotient rule. You can see even I got one step wrong, I cancelled it and I carried on, and you get the answer as required, which is x plus 5 over x plus 1 cube. Okay, and we go to question 3. So p is equal to 15 e to the 2.5t. When t is equal to 0, p is equal to 15 e to the 0, which is 15. So the population is 15,000. When p is equal to 30, 15 e to the 2.5t equals 30, and that works out to be t equals to 1 over 2.5 ln 2, which is 0.277 years. And when p is equal to 45, you do the same calculation and then you get 0.439 years. So the time taken to triple from the double is 0.439 minus 0.277, which is 0.162 years, or roughly 59 days. Okay, and question 4, fx equal to 2 minus root of x minus 1. So x minus 1. So to find the range here, I mean, you could sketch a graph, or I just used algebra to work it out. So if x minus 1 is greater than or equal to 0, because x is greater than or equal to 1, so root of x minus 1 is greater than or equal to 0. We're taking the positive root here. So minus of root of x minus 1 is less than or equal to 0. So 2 minus that is less than or equal to 2. So therefore f of x is less than or equal to 2. So I know this is a bit of a tricky question, this range, but try and follow the steps and try to make sense of it. Okay, part B, so let y equals to 2 minus x minus 1. I just swap x and y, so x is equal to 2 minus root y minus 1, and I just made y the subject, and you get 2 minus x squared plus 1. So f inverse of x is 2 minus x squared plus 1. X is a real number, and x is less than or equal to 2 because the domain of f inverse is same as the range of f. So obviously if you got the range wrong, then you would get this domain wrong here as well. Okay, question C, 2 minus root x minus 1 is equal to x. 2 minus x equals to root x minus 1. If you square both sides, you get 4 minus 4x plus x squared equals to x minus 1. X squared minus 5x plus 5 equal to 0, and x equals to, I just use the quadratic formula. You could complete the square if you want. And then for part D, p is also equal to 5 plus root 5 over 2. Okay. Okay, question 5. Okay, for this question, for the last part, I'm going to allow marks for everyone because obviously it's a bit tricky to solve, and in fact it's not solvable at all, so because there's not enough information given. But anyway, the first part, question A, part 1. So y equals the modulus of 3x minus p. We are told that p is a positive integer, so when x equals to 0, y is equal to p. When y is equal to 0, x happens to be p over 3, so it's a v graph like this. And then for the second part, y is equal to modulus of 3 x minus p plus q. So it's just basically the first graph just translated q units up to the y direction. Okay, so you've got to write the coordinates. So the y coordinate changes from 0p to 0p plus q, and the x coordinate here is p over 3 and comma q. Okay, part B here. So this is the bit I'm allowing full marks for everyone because the question is slightly misleading, so it's not solvable, but you can still solve it a little bit. Just ignore the second and third line there. So when x equal to 3, q 9 minus p plus q equals to 15 over 2 minus 2, so you end up getting basically modulus of 9 minus p plus q equals to 11 over 2. So you get two different values for q in terms of p, which is a problem, you see. So, and then you put the a in, and then you go to substitute it in. Just ignore that question because there's not enough information given on my part. Okay, now question 6. 7 cos theta minus 3 sin theta equals to r cos theta plus alpha. So r cos theta, r cos alpha minus r sin theta cos alpha. So r cos alpha equals to 7, r sin alpha equals to 3, and you get tan alpha equals 3/7, so alpha is 0.405 and r is root 58. So the 7 cos theta minus 3 sin theta equals to root 58 cos theta plus 0.405. And for the proof question, it's very simple. So 5 sec theta plus 3 sin theta equals to 7. If you multiply everything by cos theta, you get 5 plus 3 sin theta equals to 7 cos theta. So 5 equals to 7 cos theta minus 3 sin theta is required. So for this question, you got 5 cos theta plus 3 tan theta, tan 3 theta equals to 7, which is same as 7 cos 3 theta minus 3 sin 3 theta equals to 5. Okay, I know in the question it might be 3x, but it doesn't matter, we got the answers here anyway. And then you change that to the r cos theta plus alpha form, which is 3 theta plus 0.405. So root 58 cos 3 theta plus 0.405 equals to 5, and then cos of that equals to 5 over root 5. So 3 theta plus 0.405 equals to cos inverse of 5 over root 5. And now you can see I've drawn a graph here. Now this is where the graph is quite handy because theta is between 0 and pi, so 3 theta is between 0 and 3 pi. So I drew the cos graph up to 3 pi, and there are 3 intersections as you see. So 3 theta plus 0.405 equals to 0.855, or 2 pi minus 0.855, or 2 pi plus 0.855. So 3 theta equals to those values, and theta is, if you divide those by 3, this is what you get. Okay. Question 7, part 1. So y is equal to 3x squared, x cubed minus 1 to the 4. So you use product rule to differentiate it, and then you end up with 6x x cubed minus 1 to the 4 plus 36x to the 4 x cubed minus 1 to the cube. So what I did is I took 6x out of the bracket and x cubed minus 1 cube out of the bracket, so you end up getting x cubed minus 1 plus 6x cubed in the other bracket. If you simplify that, you get 7x cubed minus 1, so your fx is 7x cubed minus 1. Okay, 7 part 2. Actually, a mistake in the original answer, so here we go. So x equals to ln cosec 3y, e to the x equals cosec 3y. So if you differentiate it, e to the x is e to the x. On this side you get minus 3 cosec 3y cot 3y dy dx. Now I did a little calculation on the side here. 1 plus in the top corner, 1 plus cot squared 3y equals to cosec squared 3y. So cot squared 3y is basically cosec squared 3y minus 1 and square root of that. That's basically e to the 2x minus 1 square root. So you just put that into here instead of cot 3y, and instead of cosec 3y, just put e to the x. And so if you divide it, so you get e to the x over minus 3 to the x, e to the 2x minus 1 to the half. E to the x is cancelled. That's equal to dy dx. So therefore dy dx equal to 1 over minus 3 e to the 2x minus 1 to the half. Okay, so question 8. Y is equal to 2 sine cube x plus cosec 3x. So dy dx is 6 sine squared x cos x minus 3 cot 3x cosec 3x. You could use the chain rule to work this out if you can't do it direct.